In these last couple of problems, I wanted to challenge you to see if you could apply a few of your rules for derivatives in combination with one another. So let's look at these two problems and do just that. All right, so this looks pretty complex. We have the product of two things, right? The sine and cosine. And this is the tricky part for people, is knowing, is this a product? Is this a chain rule that we need? And so we have the product of two things. That's sort of the big picture here. We have the product of sine of x squared and cosine of x squared. And then when we go to take the derivative of each of these sections, we're also going to have to apply the chain rule because we have a composite of two functions within this right here. Okay? And the chain rule is also going to have to be applied when we take the derivative of that. So I'm going to use the product rule. And this is my u, and this is my v, all right? So when I go to take the derivative of u times v is u, so I leave that alone, right? Times the derivative of v. And when I take the derivative of cosine of x squared, I'm going to have to apply the chain rule. So the derivative of cosine is negative sine x squared. That's the derivative of the outside, leaving the inside alone, times the derivative of the inside, times 2x, right? So that's my u dv. And now I have to do v du. So cosine of x squared times the derivative of sine of x squared, which is cosine of x squared. Again, leaving the inside alone and taking the derivative of the outside, and then times the derivative of the inside. All right? Now on this second problem, we see that we have this whole thing right here to the third power. So this is actually a composite function. It's actually a composite of a composite of a composite. If I said f of x is equal to x cubed, then g of x is equal to sine of x, and h of x is equal to x squared plus 4. Then this entire function could be written as f of g of h of x, right? I think I have the right amount of parentheses there. All right, so if we want to take the derivative of that, we start with the most outside function, and we leave the inside alone. Remember, we say 3 times sine of x squared plus 4. We leave that alone, and then we drop the exponent 1, and then we multiply times the derivative of what's on the inside. And when we take the derivative of the inside, note that this is also a composite, so then we have to say this is the cosine, and we leave this innermost part alone, x squared plus 4. And then we multiply by the derivative of the very inside, so that's just 2x.